Hi students, can you see me and hear me? මාව ඇහෙනවද පේනවද? Hello?
Yes, sir. We can hear you,
Oh,
sir.
yeah. So today we are about to start very important part that is called the resonance, right? The resonance part that we are going to do. In the last week we had so much of disturbance, even that suddenly is disturbance, and actually my cat passed away last Wednesday. That the beautiful one. So after that day, I'm having a class first time in this one. Actually passed away exactly in this position. That's the most painful thing to consider about. By the way, I have to bounce back and do everything. So yeah, I'm having my class now. Yes. The Bengal cat looking one. So what to do with it? Only 9 months old. That's how the life it is. So by the way, I'm about to start very important part, right? The subtopic, very deep topic. It is a very huge topic, right? Resonance. Quite a huge topic that resonance. And let's see what is resonance all about. Resonance. Right. I told you most of the people just do resonance lesson as a part of what do you call simple harmonic motion lesson. Yes, that is the exact position in the syllabus. Yes, but this is the right moment to teach, according to my opinion. That is really applicable. So rather than learning that in the simple harmonic motion, here in the resonance part, then we can really understand what is resonance and how to apply directly without letting it to fade away from your memory. හරිද? ඒ නිසා හරිම දැනදිත් මම ඔකයි පොඩ්ඩක් ඩිලේ කරලා තියන්න කියලා දෙන්නේ. This is the correct position, correct time and correct everything. හරි? Correct everything. So okay, let's focus everything on here. Now write the definition, the meaning of that definition. Resonance, right? Resonance. Let's write. Write like this. The frequency, the frequency, the frequency, the frequency that an object, that an object, that an object oscillate with, oscillate with, oscillate with, oscillate with maximum amplitude, maximum amplitude due to an external, due to an external source of vibration. External source of vibration. Where the marker set? Amplitude max. At this moment, we call F naught. F naught is the natural frequency. Right? That means an object can have any vibration in the universe, any vibration, any frequency. But the object can oscillate with the maximum amplitude only one certain frequency. That is what we used to call as the natural frequency. Every object has its own natural frequency. Right? Number. Give me 1 second. Sorry. This is the maximum amplitude F naught. Now, right? F naught is what natural frequency. Natural frequency. Shall I tell you a good story that we use natural frequency? Good example is we normally use something called microwave oven. Microwave oven. In microwave ovens, so what every food, even dry, what do we call again? Corn seeds. Even in corn seeds, they have amount of water, right? Amount of water. That is H2O. H2O molecule has the same exact oscillation of microwave, MW, microwave, right? Has the same oscillation of microwaves, right? So they just oscillate water molecules very fast, rapidly. So the water molecules will collide with each other. They collide with each other. The problem is, then it produces some amount of heat, right? These collisions may produce some amount of heat energy, thermal energy. That thermal energy will spread throughout in the container, whatever sheet of the grain of what did I say, corn, again, then it becomes popcorn. So, or anything. If you are going to bake a cake, so cake contains the what do we call dough? No? That dough contains, right? Dough contains some amount of water inside it. This water just going to get oscillate and produce heat. That is the reason why in the microwave ovens can get bake a cake. Then the one day most of the ovens are not microwave. Normally they like the heating elements are there, but advanced technology we can also make microwave oven. So that is the same reason why whenever you make long phone call, this entire region getting heated up, even though you hold the phone like little bit away. The reason is why. In that case, we use microwave. Microwave easily get absorbed to water and just generate some heat. That is the same reason why they suggest like it affecting your brain, loss of memory and all the things. All due to what? This type of condition. හරි. මේ වගේ දේවල් නිසා තමයි ඒක වෙන්නේ. හරි? Understand? So that is why it happens. So this is the normal thing. But we have to really be careful about this type of incidents, like so exposing to radiation. But that is a simple example. So the resonance has some other samples as well. So now all the radios, right? In a radio station, it produces radio, right? Radio station, radio. Now there is a house. In that house, there is a small radio. The radio has an aerial. In the aerial, it produces the same wave inside it, absorption wave. So from the aerial, it just transfers to there is a coil. That coil resonates according to the signal comes in. So that produces small electromagnetic pulse inside this radio. Then in the radio, it develops and sent to the amplifier. Then in the amplifier, there is a speaker. That is why we produce sound. That is also due to electromagnetic resonance, right? Resonance. In chemistry, you will like to know something called resonance structures. That's a different case. But here, electromagnetic resonance. And that is not all. So if you tune 100 identical violins to the same tension, all the strings in the same tension, you keep all the violins in the hall, you just only play one violin, all the other violins will begin to play automatically. Holma. All the Guram Holma. Pagano. Galagam. One or violin. That is why. It is the same frequency, natural frequency. That is why it begins to oscillate. So even in the last week, what we learned, මම ගිය සතියේ ටික කියලාම එකයි කරේ මම ගිය සතියේ මම ඉච්චර ඕක පටන් ගත්තීම කරන්න හිටියේ බෑලමයි මගේ මේ ගිය සතියේ මයින්ඩ් එක පොඩ්ඩක් මදි මට තේරුණා උසර මොනවා හරි වෙන ගමන් තියෙන්නේ කියලා හරි ඒක නිසා කන්සන්ට්‍රේෂන් එක පොඩ්ඩක් හොඳට තිබුණේ නැහැ I felt like at least just dying but in my mind I was saying like no it will bounce back like that it was a hard period what to do හරි බලන්න this is also because of natural frequency. It has a natural frequency. That is why it resonates at fundamental frequency. First overtone, second overtone, third overtone, like that. Right? Yeah. So that is a physical event, playing the same violins at the same time. I want to ask you something. Haven't you seen this thing? Opera singers in one of the most popular opera house in Australia, that's Sydney. You may have seen some videos at least. දන්නේ සිඩ්නි වලට ගිය ළමයින් ඉන්නවා. හරිද මම නම් ගිහලා නැහැ. හරිද ඒ කියන්නේ වීඩියෝ වල දැකලා තියෙනවනේ. I have seen in videos that but opera singers just sing like woo. Then they can just crash actually crack it's a glass wine glass. The wine glass just get cracked due to the resonance of their tone. That's the resonance. And these were like something, but I would like to tell you something. Resonance has some bad effects. Yes, resonance has some bad effects. Good example is sometimes when lightning, you may hear windows just flutter like this. That type of. If the lightning occur very loudly, it has the potential to shatter the window completely. Glass kadla kuddu karala danna puluwan. Yes, it has that ability. Hari, එහෙම වෙන්න පුළුවන්. හරි. It has that ability. Right. And that is not all. I can't remember the aeroline. It was like Lockheed or I can't remember the Boeing or something. My mother know. But they had a specific aeroplane that had a problem. When landing, it shattered all the windows in airports. No airport were just willing to get that flights to them. So they had a very big issue, right? They had to fix it because producing an airplane is a really high risky thing. They have to sacrifice millions, not millions, billions to invest billions to experimentations. They have done everything. They created the model engine to create engine and all. They have already modeled the molding and all. So they can't step back, but they can't move forward. Even no airport is willing to get them because it shattered the windows. Then they invited all the scientists in the world to just solve the problem. And solve the problem. But no scientist could resolve the problem. The airline found really difficult at that time because they have to just set the aeroplanes to fly, but they couldn't. Finally, a Sri Lankan professor, I can't remember, he was a Tamil professor in Jaffna person, but who taught in Peradeniya University as the vibrational professor. He had just asked himself, like saying, I can solve. They might have just shocked a Sri Lankan professor. How can he solve this? But they had no other option. They have allowed him. He had done some experimentation for a few months or years. I can't exactly remember the time period. Imagine like 5 months or 6 months or something. And done the experimentation and observe everything. And he found a solution. And thanks to that, they just overcome that problem. And those aeroplanes again got back to work. And he runs really amazing thing. So they really wanted him to be with them forever, but he refused it. And he said like he might have taken the money for the duty, but he didn't remain there. He had said, I have a really big responsibility to teach my poor students back in Sri Lanka rather than staying here and enjoying all the treat from you and earning billions. He has just refused and came back to Sri Lanka and served very long time. I think like 2 to 3 years ago, that professor passed away. He's very old. But there are certain people like that. They really love the country, regardless of the nationality. Still, he is a very proud Sri Lankan. Sinhala, Demalada, Kiranas, Sinhala. So I have seen every nationality in Sri Lanka. There are good people, there are bad people. He was a gem. Vibration professor. See? Resonance problem. Resonance was a very huge problem back in First or Second World War. I can't exactly remember that. But German was the leading front line of what? Modern technology, not the America, not the USA, right? German was the superpower. They invented everything. So during World Wars, they could say entire bridges just collapsed when the troops were walking over it with no blast. People thought like Germans have invented another technology to blast bridges when what? Soldiers are walking over it. But this frequently happened. They realized something. It is not a problem with German technology or something. That is the soldiers themselves have done that problem with them. Why? Soldiers don't just walk. They just, whenever they walk, they just do a certain special march. They just hit the foots with everybody hit the wood in the same time. If the hitting frequency and the natural frequency of the bridge itself tally, what happens? Then the bridge begin to oscillate at the maximum amplitude. When something oscillates at the maximum amplitude, that means the particles have highest possible energy they can have. So instantly the structure break down. Right? The structure instantly break down. So that was a huge, very big problem for them. ලොකු ප්‍රශ්නයක් වුණා. ඉතින් යාලා කොහොමද ඔක විසඳගත්තේ? How did they do that? So after that, all the troops in the world never did march past when they were just crossing over bridge. They just walk like Polayano. Even dancing like a Peraharathi, forbidden on bridge. It might just break down the bridge and create huge problem. Now we know what's happening. So there are good things and bad things in what? Resonance. Resonance is a really good thing if you use good way, getting all the big advantage out of it. Resonance is a very bad thing if you use it wrongly. A willingness, even with no will to do a harm, but bad practice can also lead to very problematic situation. Right? That's how it is, right? That's how it is. Is there anybody who is adopting kitten? I have made a very mistake. I didn't know that. It's that fatal. If you are adopting kittens, please give them tricat vaccine. හරිද? දෙන්න කලින් බලන්න උනද කියලා. මට මගේ කාට දෙන්න try කරලා දුන්න පාරක් ડોක්ටර් කාට යද්දි හැමදාම උන. Doctor said like can't give vaccine if any of these viruses they are in the body, cat would instantly die. So just give them the tricat vaccine. Otherwise, it will be really painful. I can't really even think what have I done. හොඳින් ඉන්න දවස් වලට මට ගෙනියන්න බැරි වුණා. I was super busy. When I was not busy, the cat was sick. It's the fate, I think. ඒක තමයි live fate. So give them the tricat vaccine. Otherwise, this thing is really painful. I witnessed what's happening with him. It's really unbearable. I'm pretty sure this pain will last all my life. It's a very painful event because I could have saved him if I have vaccinated him earlier. Right? Vaccine එක දෙන්න බැලුවගේ ප්‍රශ්නයක් තියෙනවා. After that, I had to give him like hundreds of vaccines. Useless. Yes. ඉන්නවනම් vaccine දෙන්න. Right? Okay. Resonance. That is what resonance. So I have given you a good account of what is resonance and good effect and bad effects. Now we have to use resonance in our favor. Now it is the time for it. We have to use our favor. Now, right, the oscillations can be categorized. Oscillations can be categorized in oscillations can be categorized in a specific way. Number one, undamped oscillations. Undamped. Damped වෙලා නැති. Undamped. Undamped oscillations. Firstly, undamped oscillations. Undamped. All right. When there is no loss of energy to the surrounding, of an oscillation, when there is no loss of energy to the surrounding, of a sorry, to the surrounding of an oscillation with time. We call it undamped oscillation. No energy lost. Okay. The amount of energy remaining unchanged. The amount of energy is conserved, doesn't change, right? And in the same time, energy unchanged. So the amplitude remaining unchanged, right? These are proportional, so unchanged with time t. Time and frequency are created, right? With time, it doesn't change with time. This is what undamped oscillation. Undamped oscillation. You can write like undamped oscillation. Undamped අඩු වෙන්නේ undamped oscillation. හරි undamped oscillations. මේක කියන undamped oscillations කියන. හරි. ඊළඟට ලියන්න. එඳ ගන්න බලන්න. The next thing is under-damped oscillation. Under. Immediate. Podda. Under-damped oscillation. Under-damped. Under-damped. Under-damped oscillations. Energy loss, amplitude loss. A to the power 2. Energy is just proportional to the power 2. A to the power 2. So, if energy drop, this drop critically. Energy drop, this drop critically with time. Time may take. It reduces. That's how it is. That's how it is. Right? That's how it is. With time, it keep reducing. Okay, I'll do it again. Under dam, under dam, make under dam, under dam, under dam oscillation. Right. Over dammed oscillations. Over dammed. Over dammed. Again, dam penekawa immediate. Immediate. It takes longer time. Over dammed. Over dammed oscillations. Over dammed. Over dammed is something like this. Over dammed. Over dammed. Over dammed. Over dammed. This is over dammed. Headache grammar again, over dammed. Over dammed. But in the term test, we might get that over dammed. Over dammed. Like that. Last thing, whatever. Critically damped, critically damped. One shot damp කරලා දාන්න. මේක මොකද්ද? Critically damped. Critically damped. Critically damped. හරිනේ? Critically damped. Critically damped. Critically damped. Critically damped. Sorry. Can you explain two specific way mean? Two specific way mean? Two specific way mean which one? කොයි එකද? Under damp means with the time. Right. Have you ever seen something like, have you ever ride the swing? Manchili pedala dinawada? Ride the swing like this. You get one full swing and you let it to continue automatically without providing any external support. Nobody pushes you. You are not getting your own energy applied. Have you done that? Nobody gives the energy and you are not providing energy even. So what would happen? The swing will just oscillate, 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 and oscillate, and oscillate, and oscillate. Finally, after some time, it may comes to rest. That is what type of oscillation? Under damped. Within the time, each swing, it just leaves some energy to the surrounding. So as I explained you, energy is proportional to the A to the power 2. So if the energy drop, A drop graphically. Understand? Overdamp means, so somebody just coming with the swing, you want to stop him quickly, you just stop very forcefully, come to stop very slowly, and that is an overdamp. But critically damped means you just hold and stop. You understand? Critically කියන්නේ නිකන් ක්ලේ ගුලියක් ගිහිලා බිත්තිය වදිනවා කියලා. May just get stopped instantly. Do you understand difference? Okay. Fine. Now it is the time for us to learn. Right. Everything done. The sounds can everyone. Now it is time to write very huge topic. Speed of sound in the air. 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 Then Anna. Speed of sound in the air. Yonder. Sound wave. Sound wave. Sound wave. Sound wave. Sound wave is a sound wave is the speed of sound in the air. Sound wave is a longitudinal wave. Longitudinal wave, and it is a mechanical wave. And it is a mechanical wave. So it travel by compressing. So it travel by compressing and relaxing the medium in the air. Yeah. Right. Right. Like this. So the basic formula like this. So the basic formula of speed of sound can be written as following. They are my basic formula. V is equals to direct application gamma P divided by rho. Gamma P divided by rho. Just like this. V is what? Speed of sound in the air. P stands for pressure. P stands for pressure. Rho stands for density. Density. Speed of sound in the air, pressure and density. Pardon? Pressure and density. Pardon? Speed of sound in the air, pressure and density. Pressure and density. Pressure and density. Pressure and density. Sorry. Pressure and density. Sorry. There is a gamma. Sorry, I forgot. Gamma. The ratio, I forgot. The ratio of the specific heat capacity of air. In the thermal physics, you will get to know what is actually gamma is. Then equation gamma Cp over Cv. Constant pressure thermal capacity and constant volume thermal capacity. These are two different things. Constant pressure thingy has more specific heat capacity than constant volume. You won't understand these things right now because you don't know anything about Boyle law. You don't know anything about Charles law. You don't know anything about Gay-Lussac law. You don't know anything about universal gas equation unless all the things has done in chemistry so far. Chemistry the universal gas laws are even if you have done those things, you don't know anything about physics. In chemistry, physics right now, apart from all level physics, you have learned specific heat capacity. There is also don't know, you don't want, only you need this, the ratio of specific heat capacity. That's the only thing you need. Okay. If we get certain equation, we have to check whether it is right. We have to check it whether it is right. බලමු ඇත්තද කියලා applying values for මේක අපි දන්නේ නැහැ. Pressure I can get like the atmospheric pressure 1 into 10 to the power 5. Okay. Density is nearly like 1.2 kg m minus 3. This ratio is normally like 1.4. 1.4. Right? 1.4. හරි ළමයි පොඩ්ඩක් අපි දාලා බලමු වෙනවද කියලා. ඔයාලා දාලා බලන්න. එවෙන් සීරුවේ. එතකොට නේ අපිට තේරෙන්නේ මේක හරි ඇත්ත කියලා. නැත්නම් මම කියනවා ඔයාලා ලියා ගන්නවා. එහෙම හරියන්නේ. එහෙම හරි. Rho is just 1.2. It is nearly like what? 6. Here it is like 7. Hurry. So I can make it even now. It's like 70 into 10 to the power 4 divided by 6. 0.2 ඒවා ගත්තේ 0.2 ඒවා හතක් තියෙනවා 0.2 ඒවා හයක් තියෙනවා right 70 times. It is about 70 times. Now I can get like 35 over 3 times 10 to the power. හරි. මෙයා නිකන් 36 කියලා මම ලේසි කරන්න ගන්නවා. 36 කියලා මම දාන්නම් කියන්නේ. එහෙම බෑ. එහෙම බෑ. But for my convenience I will just arrange it. එහෙම ගන්න බෑ. මම මේවට මැත් එකද කියලා දෙන්න ඕනේ. ඒ නිසා මම ගන්නවා මේක 36 over 3 කියලා. 10 to the power 4 comes out. 10 to the power 4 comes out as 100. It is 12. ළමයි 12 එක අපිට වන්න ගන්න පුළුවන් හරි ලේසියෙන්. හොඳට බලන්න. හොඳට බලන්න. 100 here. Well, I can write like 4 times 3. So 4 is just 200 by root 3. Root 3 is nearly, you know that 1.7. So I made it bigger. So I'm not going to take second decimal place then. This path to compensate that, I'm not taking the second decimal place. 200 times 1.7 only. So the speed is nearly 340 meters per second. Yeah, man, this is the speed of sound in the air in tropical lands like Sri Lanka. Lanka වගේ තැන්වල ඔක තමයි speed of sound. That because the help of humidity, you will get to know instantly why this today itself. ඔක දාගන්න. ඒතර මම කියනවට අට බලන් කරන්නේ නැහැ අපි. දාලම බලනවා ඇත්තද කියලා. ඔව් ඇත්ත. හරිනේ? Isn't that nice? Make a nice name. Huh? Sorry. Done. Hurry. Cargando. Okay. Hurry. Cargando. Hurry. ඇති දැන් අපි ටක් ගාලා ලියමු ඒක දාලා increase or decrease of pressure or density. Increase of or decrease of pressure or density. It's a mutual process. දෙකම එකට සිද්ධ වෙන process එක. It's a mutual process. It's a mutual process. Right? Mutual process. Right? Mutual process. Right? Mutual process. So, any effect cancel off with the other. Imagine you increase the pressure by 2. Pressure means number of particles increased. As the number of particles increased, density also increased by 2. So these two effects cancel off. It has no effect. Do you understand? Pressure එක වැඩි වුණත් density එක වැඩි වුණත් කිසිම effect එකක් නැහැ. එහෙනම් අයියෝම equation එකක් හැදුවේ කියලා හිතේ. බලන්න එපා. If you learn physics in the university level, you will get to know everything why it is. In the first year itself, the derivation of this equation itself is nearly costing 2 pages. That is also, if you are really good at calculus, you can avoid some other steps in your mind. Wage mind එකෙන්ම පුළුවන් සමහර step නොකර ගැනීම answers දාන්න. Otherwise, it will run more than 45 pages. The derivation of this cell. Right? ඒක මඩුව අතල දැන් මේක දාගන්න. So pressure or density has no changing effect. Changing effect. Now, derive කරන්න ඕන වෙනවා changing effect එකක්. No changing effect. Right? Hari. No changing effect. Now can try with universal gas equation. Have you learned chemistry about universal gas equation? You know anything? Chemistry wala? Yes or no?
Yes, sir.
I am going to work with this one itself. So let's see how it is. Let's see. Now this is equation X. I want to introduce P V equals to nRT. This is universal gas equation. If there is any IT student, ask me, I will explain you. If everybody is a chemistry and already done, no need to explain. මෙතන ඉන්නවද IT හරි කරපු නැති හරි කවුරු හරි ටක් ගාලා කියන්න. Let me know. Anybody? Is there anybody who hasn't done universal gas equation thing yet? Huh? It's a part of simple physical chemistry. Oh no, නැත්තන් නැහැ. හරි. කරලා තියෙන්නේ P for pressure, V for volume, N for number of moles, R is for universal gas equation, and T is temperature. I can get P subjected from here. P equals to what? N R T over V. This is what equation Y. This is what my equation Y. Hari. දැන් මම ගිහින් දානවා equation Y එක x වලට. හරි. Gamma is there, rho is there. Now I'm introducing this thing into that. What? nRTOV. See what happened? It's very beautiful. nRT over V. Right, my dear students? Tell me what is the relationship of rho into V? Again. What is the relationship of rho into V? Density into volume. What is that? We know this. Density is equal to mass over volume. Mass is equal to density into volume. So this is none other than mass. Mass. Right? දාගන්න ඩක් ගන්න. gamma n r t over simple m. Simple m. You can see now something very important. Maybe step by step I will explain you. අග්ගාල කරලා දැන් 20 seconds more for you. 20 seconds more for you. Right. As I know, number of moles equals to mass over molar mass. So when you get a number of moles over this, n over simple m means 1 over molar mass. Right? That is none other than 1 over molar mass. So the finalized equation will look like this. See? V equals to gamma r t over capital N. Gamma r t over capital N. Gamma r t over capital N. හරි. මම හිතනවා ඔයාලා හැමෝටම ඔබ තේරුණායි කියලා. හරි. I'm pretty sure everybody understood this very well. Emily, tell me yes or no? Hello? Yes or no? Hello? Now I'm going to drop a message to Paradu Physics device. Please. Understood this or not?
Yeah. Yes, sir. I can't hear you properly, sir. My network is not in a
right.
good.
Just අනිත් ළමයි මොකෝ. හරි. අපි යමු share screen එකට. ගිහිල්ලා කරලා ඉවර කරන්න වැඩ ගොඩක් තියෙනවා. ළමයි මට support එක දෙන්න ඔයාලගේ. හරි. මට support එක දෙන්න ඔයාලගේ මම හැමතිස්සෙම කියනවනේ. Because now you can see how the people are stupidly fighting with the government to extend the exam time. Because those teachers could not complete their syllabus. යාලගේ syllabus එක ඉවර කරන්න බැරි වෙලා. හරි. They are fighting with the government. Government is not listening to them because they had enough time. Those people dragged and rubber the first lesson, then rubber the second lesson, tried to rubber the third lesson as much as it can until them to sign for the exams. Then they only began to teach very fast. They put like 4 to 5 to 6 hour class and double class, triple class to cover up the syllabus. Then they found a time factor. Now they have just screwed themselves up. You can see that. Right from the beginning to my last batch, that means 2006 batch, 5 batch, 4 batch, and all, I just told them, you will run out of time. This time, it's completely ran out of time for them. But luckily for my students, I have completed the syllabus for them. Nowadays, we are having revisions during the theory class time. Theory class time, revisions. specific point wise revisions, paper discussions, strategies, and the writing skill, and all we develop. I think ඒකට support එක ඕන. හරි. The student count here it is very low now. It's like 5 to 6, 7 students. I don't care. I don't mind. Even though there is one student who is willing to stay with me, my aim is to give him or her best opportunity what I can offer. Right? I never do like, right? I never ever do like what? Slow rubber way, because I know time is very important. Time is extremely important. If you're running out of the time, that's done, and that's very bad. In the time again, hari varisam wenda, hari. Give me a support. I will bring to you to very high results. අනිවාර්යයෙන්ම ඔයාලව තිය ගන්න පුළුවන් ලොකුම result එකට මම ගෙනියනවා. ඒක මගේ පොරොන්දුව. It's a
Thank
promise.
you, sir. Thank you,
හරි.
sir.
ඒක නිසා මට support එක දෙන්න ඉක්මනට ඉවර කරන්න. බබාලා ඉන්න එපා. මේ අමාරු පොයින්ට් ඉක්මනට කරලා ඉවර කරොත් තමයි හරියන්නේ. ඉතින් මීට ඇදලා දීලා කොහොමද exam එකේදී මම ඔයාලව කව කරලා දෙන්නේ. මටත් ඉතින් ආණ්ඩුවට බයින්න පුළුවන් මේ අකු exam එක ළඟ තිබ්බා. It is useless. We had enough time. හරි. ඔයාලා දන්නවනේ ප්‍රොෆෙසර් කරා රෙමි දැන් යාලා අර ඔයාලා අවිලා කතා කරේ මුල් දවස්වල. හරි ලස්සනට වැඩ ටික කරන් ඉවරයි. සිලබස් ඉවරයි. I finished almost like 3 months before the exam. Not more than 2.5 months before the exam. They have that luxury. They can enjoy in the exam. Right? Because they had enough time to rectify all the mistakes, even in the last few lessons. Last few lessons are very important, but students don't have time to refer those things. They don't get any single mark from those lessons. එහෙම බෑ එකක් ගන්න. හරි. ඉතින් ඔයාලා මට සපෝට් එක දෙන තරමට මම ඉක්මනට ඉවර කරයි. හරි. අපි යමු ෂෙයාර් ස්ක්‍රීන් එකට. ඉක්මනට ඉවර කරගමු. Let's finish this as quick as we can quickly. And one more thing. Tomorrow I'm going to give some kind of an arms from my side to my cat, and you can also wish him a good life, next life, right? Well, one wish might work very well than my own wish. හරි. මොකද මේ අර වයිබ් එක සමහරක් විට ඔයාලගේ වචන වල සෙට් වෙන්න තියෙනවා මගේට වඩා. ඒක නිසා ඒ එක විශ් එක අනිවාර්යයෙන්ම help වෙයි. හරි. Whatever the religion you adhere, wish him a good afterlife. Okay? හරි. තරදාලා අපි යන් share screen එකට. Let's do very tremendous amount of work today. Okay? Let's do. All right. Calculate the speed of sound in the air. Speed of sound in the air at temperature of 27 degrees Celsius. Temperature of 27 degrees Celsius and average molar mass is 30 grams per mole. Hari. තව පොඩි දෙයක් දෙන්න. R is equals to 8.314 J mole minus 1 K minus 1. This one we can take with that approximation. I normally use this normally apply this in the equation. Then in my rough sketch, I use this. Very practical way is 25/3 because nearly equal. When numbers they come almost same. Right? Almost same. මේක නිසා බය නැතුව simplify වෙලා යන්න නැති දැන් වලදී බය නැතුව දාන්න 25/3 there might be a chance to simplify. හරි. ඕන කරන උදව් ටික තියෙනවා and gamma is 1.4. It is a ratio, no unit. Right. For the first question itself, I will rewrite the equation for you to apply gamma R T over capital N. Now try this question. Try करें. Let's see how to apply. V is equals to gamma, that means 1.4. R, I will apply like 25/3, okay, for my convenience. And for temperature, if you apply like this, 27, that is wrong. Why? Temperature is thermodynamic temperature, that should be in Kelvin. Since your O level, you know how to calculate Kelvin from Celsius. Kelvin is 273 plus whatever the Celsius value. So the Kelvin answer for here is 273 plus 27. That is just going to be temperature. Temperature is equals to 300 Celsius Kelvin. Now I'm about to apply 300 Kelvin. 300. Okay. So the mass is nearly 30. Right. If you just apply 30, that is also a big problem. Big, huge problem. Okay. 100. This is not just 30. 30 into 10 to the power minus 3 by, it is gram. It is gram. So now, get it like 1.4 multiplied by 25 divided by 30 with a capital the guy comes up 200 and that becomes 10,000. 10,000. So here it goes up. Divide by 3. I can take 5 out. That's going to be just 5 by 100. That is also out. 1.4 over 3. So I can make it like 14. Rather than 14, I make it like 140 over 3 into 10 to the power minus 2. Minus 1 comes out 2. Minus 1 එකක් එළියට එනවා. මම එහෙම කරේ strategic move එකක් because that can come out. So in the next one, 500 into 10 to the power minus 1 comes out. So I can cancel off, I can cancel off 1 0 from here now. 1 0 from here now. So it is very stabilized now. So what is the answer now? It is coming up
140 over 3. So technically for my convenient only, I make it like 141. Like 141, I can divide by 3 because 120 is 40, 3 times 4. So I can divide 3 times 40. So, and 7. So I can get it like here 47. 47. Okay. 47. Nearly 47. I can make it like 141 for my convenient. Hari, convenient එක හදාගන්න. 47. Right. Now the problem is v is equals to 50 root 47. Hari. Can't you remember I show you a very universal method of finding any root very quickly? How? Can you remember that specific method I told you? Whatever the square root is equals to approximated number, okay? Approximated number plus or minus what? Approximated root. So the approximated number minus, what is that? This one, what do we call, whatever we're finding as the square root? Huh? So, and you have to divide it by, approximated number divided by whatever the square number, divide by 2 times approximated root. මතකද ඔහොම method එකක් කියලා දුන්නා? එහෙම එකක් කියලා දුන්නා මතකද? මතක නෑ? අයියෝ. මතක නැද්ද? ඔහොම එකක් කියලා දුන්නා මතක නැද්ද?
No, sir.
කියලා දුන්නේ නැද්ද මම ඔයාලට? හරි කමක් නෑ දැන් දාගන්නකෝ. ඔක ලියාගන්නකෝ. හරි. මේ කියන්නේ අපිට ඕන කරන ස්ක්වයර් රූට් එක. What is the approximated root for here? 49 is very close, other one is 36. This is not closer, 49 is the one closer. Hurry. So it is 49 plus or minus, here the difference, approximated one. Okay. Sorry, me dekha maru wenna one. Here the square root minus approximated one. So here, what is the square root? I want to find the square root of 47. The nearest one is 49 divided by 2 times square root number is 49. 49 root is just 7. So what is it? 7 plus or minus, you have to divide what? 47 minus 2 is minus 2 divided by 2 times 7. Pardon me? 2 times 7. Now 2 and 2 cancel off. 7 minus 1 over 7. 7 minus 1 over 7. First multiplication, it becomes 49 minus 1 divided by 7. 48 over 7. How many 7s are there? 6. And the difference is just 6. So in 6, nothing. For in 60, how many? 8 there and 4 remaining. 4 remaining means 40 is about 5. This much. So you can just multiply this by 50. Answer will be, what is the answer? I can make it another difference. 50, I can write like 100 over 2 multiplied by 6.85. I will make it like for my convenient 86. So I can easily cut this off. 3.43. So the speed nearly be 343 ms minus 1. Isn't this the value we normally get for the tropical beast? It is normally around 340. So answer is correct. Arni, answer is correct. Hari, answer is correct. Hari ටික ලියාගන්නකො මම හිතනවා PDF එක ගන්න මේ අද කරන්න වැඩි. ඒක දන්නම ඉවරයිනේ. හරි. තමයි මේ
මේකෙන්
මේකෙන් තව
ටිකක්
ගණන් ටිකක්
ටිකක්
ගන්න
කියලා
තියෙනවා
දෙන්න.
කියලා. Okay. All right. Next thing. So the speed of sound, India is only depending on with two factors. Only depending on with two factors. Sorry. Factors දෙකයි තියෙන්නේ. මොනවද කියලා බලමු. V is equals to gamma R T over M. Right? Gamma is a constant specific seat capacity ratio that is for diatomic molecules mostly because in it contain oxygen, that's a diatomic, hydrogen, that is a diatomic, very පොඩ්ඩයි තියෙන්නේ, and nitrogen diatomic, carbon dioxide is very rare, any other gas is very rare. Normally more than 99% is made out of what? Normal things means diatomic molecules. For diatomic molecules is 1.4. Other contribution is negligibly very small. So ups and downs are there according to triatomic and biatomic things. So as a result, so we can nearly take what? Gamma as a constant. This is a universal gas constant, but temperature go up and down can happen. Molar mass may also change according to place because the humidity play a very vital role in molar mass. Some areas have higher molar mass in countries like England and those where according to like winter season especially. But in Sri Lanka and India, these countries are really highly prone to have high humidity. Humidity means low density air molecules, water vapor mixing with the air. So it reduces the density. Density reduce mean average molar mass reduce. Okay. Then the speed of sound increase. So we have to compare these things. Now, right? You wrote no? Only temperature and molecular mass effect. So now we can show that. Now, right? The effect of temperature. The effect of temperature. Let's get the effect of temperature. So volume is velocity is directly proportional to temperature only because these are constant. If you just consider the mass is also constant, this is directly proportional to temperature. Hari? Hari? දැන් ලියන්න. දැන් ලියන්න. The speed of sound in the air for two different temperatures. For two different temperatures. Sorry. For two different temperatures. At T1, I can consider it as V1. Okay. At T2, I can consider it as V2. Okay. Now here see, V1 is directly proportional to T1, square root of T1. Here I can write like V2 is directly proportional to T2. Right? Here I can consider like the mass is constant. Mass is constant. Other two things are also constant. No need to worry about this if the mass is constant and temperature change. So now it is like equation 1. This is like equation 2. I can divide equation 1 by equation 2. So the equation just becomes V1 over V2. That is equals to square root of T1 over T2. Finalized. Very easy. In this method, practice this. Even in the last year, there were like 2 MCQs came in this exact condition. Anivaring, but easy. Okay. Alright. Sorry. දැන් ලියන්න question එක ලියමු example speed of sound India at 27 degrees Celsius air at 27 degrees Celsius is what? 340 ms minus 1. Okay. What is the temperature that speed reach to twice of that? Sorry. චුට්ටක් ගේමක් නැතුව හදන්න පුළුවන් දෙයක්. Very easy question. හරි. අපි කරමු. The equation is V1 over V2 is equals to root T1 over T2. If it is an MCQ, you can directly apply this. No problem. Now it is 340. So other one is should be twice means 480 now. Right? Over T1 is 27 means 300. You don't know T2. So you have to square this. Before square, cut this 1 and 2. Right? If you are even smart, you are not going to do 340 and this thing. I will show you what smart method without doing. So you have to square it. 1 square and 2 square. Then the square root 300 over T2. Also you are going to square. So that means 1 over 4 equals to 300 over T2. T2 is just 300 times 4. 2 is just 1200 degrees Celsius. Podi ne? Hari? Podi ne? Double වෙන්න 4 ගුණයකින් අඩු වෙන්න. Okay? හරි. ටක් ගාලා දාගන්න. Hari? Let me show you the smart method. It says like 340 and double means you can take this as V. Twice means 2V. අන්න එහෙම දාගන්න. V over 2V. ටක් ගාලා ඉවරයි. V ට V කැපිලා යනවා. ටක් ගාලා ස්ක්වයර් කරා 1 over 4 equals to 300 over T2. T2 කියන්නේ 1200 කියලා දැම්මා. ඔන්න ඔයගේ ස්මාර්ට් විදියට වැඩ කරන්නත් පුරුදු. Right? Try to work smart as well. Smart move කියලාත් මේක ලියා ගන්න. Smart move. හරිනේ? හරි නේද? හරි. I'm pretty sure you guys catch this up. Okay. Immediately ලියා ගන්න. හරි. Okay ළමයි. මම කරන්න. හරි. ළමයි. දැන් ලියන්න. The effect of the effect of molar mass under constant temperature. Under constant temperature. Right? We'll have a good look at here. I can write like V1. Sorry, before going for two occasions, I have to show you how it affects. Sorry, මේ දෙක ලියාගන්න හදිස්සි වෙන්න එපා. Effect of molar mass. Now, right, when the temperature is constant, when the temperature is constant, we can rearrange the equation in the following way. V is equals to square root of gamma R P over capital M. So see, gamma is a constant, R is a constant, T is a constant. Only variable is M in this time. Mass can go up or down. So technically you can write like this way. Velocity is proportional to square root of mass. This is very important to remember. Square root of mass. Right? Firstly, get this one. Don't write this. Copy the other things. Okay. Now write. Compare the velocity for two different molar masses under same temperature. Then මොකද කරන්නේ? Two different molar masses. Compare the velocities for two different molar masses under same temperature. Different molar masses means two different samples. Okay. Now write on a bracket for different type of gases. Hari. Abhigam. Now you can write like V1 is proportional to 1 over capital M1 root. V2 is proportional to 1 over root M2. Equation 1, equation 2. Sorry. V1 over V2 is proportional to square root of M2, M1. Okay. හරි නේද? හරි. ලියලා ඉවර කරගන්න. Okay. Now write. Calculate the ratio of velocity of helium gas and oxygen gas under temperature of 300 Kelvin. Support iddanna M helium is 4 G mole minus 1. Mass of oxygen is 32 G mole minus 1. Sorry, on support එක හම්බුණා. Now try. I'm only asking the ratio. Sorry. Samrit, you have missed these things. Copy this. Effect of molar mass. පොඩි try එකක් දාන්න ටක් ගන්න. Arni? Let's try. Let's try. The ratio, very simple. V1, V2 is equals to M2 over M1. M2 is just 32 over 4. The ratio is what? Huh? It is 8, no? It is 8. Is to V2 ratio is, I can get it like, I can get 8 as 4 times 2. So 4 means 2 comes out, 2 root 2. Sorry, this was the ratio. Okay, I'm sure you understood. Sorry. Right. Then අපි last week එකේ දුන්න worksheet එකේ පොඩි වැඩ ටිකක් කරමු. Let's do some worksheet related questions. Yeah, this is a very long term test type of question. Let's try this one. So let's quickly try this. Try එකක් දාන්න. Okay. A wave can be generated in any medium, solid, liquid, and gases by vibrating particles of the medium. There are 2 types of waves when they are transverse and longitudinal waves. Write down 2 requirements that a medium should have to generate a wave. Hari. Write down. එතකොට මෙතනදී අපි හිතන්න ඕනේ මොනවද? 2 requirements to generate a wave. So definitely the first thing you have to mention is there should be a source of vibration, because it has to have a source of vibration. Okay. That, and another thing, elasticity. That means the particle have to move to up and down, to and fro, like that. Okay. Medium might be able to return to original position after being displaced. That is what elasticity means. So the particles just were like this. So the particles can just move like this and again come back to original position. That's the elasticity. Okay. Medium should have, not the, we can't mention about the source because it is about the medium. So the particle should have inertia. So to store energy, hari inertia එකක් තියෙන්න ඕනේ. Okay, if there is a mass, there is definitely inertia. No? B, distinguish between longitudinal and transverse wave motion, clearly showing the direction of transmission of energy of the vibration of particle. Okay, longitudinal and transverse waves, direction of transfer energy, transverse vertically up and down, and the movement is here. You can mark it like movement, particle vibration here in the longitudinal waves. What about here is the direction of wave travel? Particle vibration occur back and forth. Particle vibration. Hari. එක තියෙනවනේ. Number C, the velocity of the transverse waves along stretched string depend on some physical quantities. Mention them, write down the equation of mean wave velocity. It is square root of T over M. That's what? T over M. T stands for the tension and the M stands for the mass per unit length. Right? Part D. A steel wire of length 200 centimeter and the mass 40 gram is stretched between two clamps while being stretched to 800 Newton. Calculate the speed of transverse wave in this wire. V is equals to square root of T over M. Let's get the values. So let's see how it is working. So V is equals to square root of T is 800 divided by just the mass is 200 into 10 to the power minus 3 divided by, sorry, wait, oh, 200 cm, sorry, not the mass. Mass is only 40 gram. 40 multiplied by 10 to the power minus 3 divided by 200 by 10 to the power minus 2. Minus 1 remaining here. That cancel off. Hurry. This 2 also goes up. V is equals to 200 times 200. V is just 200 meters per second. Very simple. Very simple. මේ ප්‍රශ්නේ අමාරු නැහැ. The wave traveling in the above calculated part D reflect from a stationary wave and 8 antinodes. Calculate the vibration frequency. Okay, one antinode stands for what? One antinode stands for half the wavelength. Let's only draw 4 antinodes and let's get, see, 1, 2, 3, 4. Each loop, antinode stands for one loop, that means lambda over 2. Lambda over 2 times 8. That means how many lambda? Length equals to 4 lambda. Wavelength hatarak. Hurry. It has 4 wavelengths. Okay. Now you can easily find out the wavelength because 4 lambda is equal to 200 centimeter. Lambda equals to 50 centimeter. I can find the frequency. So V is equals to F into lambda. I know what is V. 200 equals to F, I don't know, but the frequency is lambda is 50 into 10 to the power minus 2 minus 1, right? So it is 4, yeah, frequency is equal to 400 hertz. 400 hertz. Are lazy, yeah? Okay, step back. If you couldn't understand any single step over there, let me know. Sorry. Step back. වගේ දැන් තමයි මම දකින්නේ ආවනේ is it Kelvin කියලා? Yes, it is Kelvin. හරි වැඩි තේරුණානේ? Any doubt you can ask. Hari. Copy this all. මේ සේරම ලස්සනට copy කරගන්න. හරිනේ? I'll give you maximum of 20 seconds more. Hari. ඊළඟට කියනවා when a small mass of dropped from a pond of depth 6.4 meter a wave මෙන්න මෙහෙම wave එකක් යන්න ගන්නවා. Travels on water due to vibration of the particles on the surface. Hari. Which type of wave form on the wave? On the water. What is the type of wave form on the water? Huh? Transverse wave. Transverse wave. What is the speed of that wave? මෙන්න මේක මම තාම කියලා දීලා නැහැ. This should be explained in longitudinal waves in liquid. It is square root of 2gh. ඔන්න ඔය කතන්දරේ පාවිච්චි කරන්න තියෙන්නේ. හරි. derive කරන්න නැහැ. ඔක පාවිච්චි කරන්න විතරයි තියෙන්නේ. ඒත් මම තාම කියලා දීලා නැහැ. So it is 10 multiplied by height is 6.4. හරිනේ? sorry ළමයි. හරිනේ? hello? hello? හරිනේ ළමයි? sorry මේ මට අමතක වුණා. මේක මේ 2 නෑ අමතක කළා මේ දැන් මේ only G and H. For water it is only G and H, no 2. So it is just going to be 64. That means the speed is 8 meters per second. That is the speed. Hurry, that's the speed. Calculate the frequency of the wave if the distance between 11 adjacent maximums 11 adjacent maximum displacement is 8 meters. Maximum displacement occur in where? Amplitude. Amplitude means antinode. So I told you one antinode stands for what? Lambda over 2 times 11. Okay, that means 11 lambda over 2 is the amplitude. So it is 8 meter. So let's say what is the wavelength? 2 times it is 16 over 11 meter. That's how the wavelength. Okay. Frequency, I can find the frequency. V is equals to F into lambda. I just found what is V. F is equals to 8 over 16 over 11. Decimal කරගෙන හිටියා නම් වා දුක් වෙන්න එනවා. අයි කැපෙන්නේ නැහැ මලකට එමන. 1යි 2යි. So this goes up 11 over 2. That means the frequency is 5.5 hertz. දැක්කනේ? අර fraction එක හැටියට තියාගෙන ඉස්සරහට ගෙනිච්චාම මාර ලේසි. If you just carry the number as a fraction itself, that will just really help you really very much. හරිනේ? කොපි කරගන්න ටික. හරි නේද? I think enough. හරි මේ බලන්නකෝ. So we have done the hardest one in that one. So now we can try past paper questions and all even, right? I mean, මට එන්නේ කට්ටිය නිදිමත ඒ වගේ ඉන්නේ. ඇයි එච්චර නිදිමත ඔයාලට? Right. Now you can actually try these questions. මේ තියෙන ඕනම එකක් try කරන්න පුළුවන් මෙතෙන් එනකම්. Now in the next week I have to do these things. I'll come up that with but rather than these questions itself, I'll come up with kind of what do we call live worksheet. හරි. මේකේ න අමාරු question set එකක් තියෙනවා. These things we have to finish very quickly. හරි. So we can try those. Okay ළමයි. එහෙනම් අපි තව විනාඩි 15ක් විතර තියෙනවා. කමක් නැහැ මොකද මේ theory කරන්නත් වෙලාවක් නැහැ, question ගන්නත් වෙලාවක් නැහැ නේ. අද අපි ටිකක් වෙලාසෙන් ඉවර කරමු. But in the next week I will run out of the time even. Time උත් මදි වෙන මට තියෙන්නේ මොකද we have to do open tubes and closed tubes in the next week. Sorry, open tube and closed tubes in the next week. So better to watch something recording to open tube and closed tubes, resonance patterns in open tubes, and search this in the internet. Resonance patterns in closed tubes, and then you can understand some of the very basic things and come up with the pre-required knowledge. හරි. එහෙනම් අපි අදට පොඩ්ඩක් ඉවර කරමු. මොකද මට පේන විදිහට ඉතුරු කට්ටිය නැතුව ඔගේ ප්‍රශ්න කරලා කොහොමද ප්‍රශ්න ගොඩාක් කරන්න තරම් තියරි එකක් කරේ නැහැ නේ තාම. In the next week we can do almost like more than half of the waves will be done in the next week. More than half, that means 60% of the wave lesson will be completed in the next day. හරි. ඊට පස්සේ අපිට තියෙන පොඩි lesson කැලි දෙකක්. Then the waves is over. You can start up with optics very happily. හරි. Okay. එහෙනම් අදට වැඩ ඉවරයක් කරමු. God bless you all. Bye.